This is Algebra Lesson 10-4, Part 1, Factoring to Solve Quadratic Equations. A quadratic equation is an equation that can be written in the form of ax squared plus bx plus c, where a cannot be 0. This form is also called the standard form. Your roots of a quadratic equation are the solutions of a quadratic equation. These are sometimes referred to as the zeros of the function, which in other words means when x is 0, or what does x equal to get to the 0 of the function. It'll make more sense when we talk about how to solve a quadratic function. Something very important, the product of two or more numbers is 0 if any of the factors is 0. That's important. So if I have 5 times 0, that's 0. If I have 0 times 3, that's also 0. As long as I'm multiplying things together, if any one of the factors is 0, the entire product is 0, because that's what multiplication by 0 means. So that leads us to what we call the zero product property. For every real number a and b, if a times b equals 0, then a equals 0, or b equals 0, or they both equal 0. So, if we have a quadratic equation with 0 on one side and a factorization on the other side, you can solve the equation by finding the values that make the factors 0. This is simply done. And for example, if I have to solve the following quadratic equations, if I have to solve x minus 2 quantity times x minus 3 quantity equals 0, that means either the x minus 2 quantity is 0 or the x minus 3 quantity is 0 because I have a solution of 0. These are both set equal to 0. To solve this, I set them separately equal to 0. So I have x minus 2 equals 0 and x minus 3 equals 0. And I solve both of those equations. I add 2, so x can equal 2. Or I add 3, so x equals 3. So the solution to this equation is 2 or 3. Because if x equals 2, I'll have 0 times negative 1, which is still 0. If x equals 3, I will have 1 times 0, which is still 0. We can check it by plugging those numbers in, and we realize that x equaling 2 or x equaling 3 gives us a product of 0. In this next problem, x times the quantity x minus 5 equals 0, you're still going to set each factor equal to 0. So we have x equals 0 or x minus 5 equals 0. So x equals 0 is already solved. Here we'll add 5 to both sides, and we have x equals 5. So the solution is x equals 0 or 5. Not a hard concept when you look at it. If they're already in factored form, it's actually really easy to solve a quadratic. Problem number 3, we have 5 times the quantity x minus 2 times the quantity x plus 3 times the quantity x minus 4 equals 0, which means either this is 0, or this is 0, because anything times 0, even if we multiply 5 by a 0, we're still going to get a 0. So we set each one of the underlying values equal to 0. We do not set 5 equal to 0 because 5 doesn't equal 0. We have to have a variable in order to set it equal to 0. There's no variable but next to the 5, so that cannot equal 0. So we have x minus 2 equals 0, x plus 3 equals 0, x minus 4 equals 0. So add 2 here, x equals 2, subtract 3 here, x equals negative 3, add 4 there, and x equals 4. So our solutions are x equals 2, comma, negative 3, comma, and 4. Those are our possible solutions to this particular equation. This last one, as you can clearly tell, people ask me, do I have to show this step? Not necessarily. But when we get into the next problem we're going to do, if you try to solve it mentally the first couple of times, you're probably going to mess it up if you don't think about what you are doing. Because here we have 3x plus 2 equals 0, and 2x minus 1 equals 0. These are both two-step equations. So here I have to subtract 2. I now have 3x equals negative 2. I have to solve for x, not 3x, so divide by 3. So x equals negative 2/3. Still not a complicated concept. You just have to make sure you're solving for x properly. On the 2x minus 1 equals 0, we will add 1 to both sides here. You will get 2x equals 1. To solve for x, we'll divide by 2, so x equals 1/2. So our solutions are x equals negative 2/3, comma, 1/2. So those are our possible solutions to that particular equation. Now, those were easy because they were already in factored form. Not every equation will be in factored form. Not every equation will be even in standard form. So sometimes an equation is not set equal to 0, so you must do the following. Get the equation in standard form. Factor if necessary. Set each factor equal to 0. Solve, and then check your answer to make sure you're right. It's always a good idea to check your answers. So let's look at number 5 here. It is in the form of ax squared plus bx plus c, so we have an ax squared plus bx plus c equals 0. So it's fine. It's in the right form, so we now need to factor it. We need two numbers that multiply together to get 12, add together to get 7. So we need a product of 12 and a sum of 7, which I believe is 4 and 3. So we'll have x plus 4 times x plus 3 equals 0. So now we'll set these each equal to 0. So x plus 4 equals 0, x plus 3 equals 0. So x will equal negative 4 and negative 3. And I kind of skipped the step of subtracting 4 and subtracting 3 each time, because I'm hoping that you kind of understood that step. If we look at problem number 6, you will see that 6 is not in standard form. We must get it in standard form by adding the 3x and by adding the 2 to move them to the other side. So we now have x squared plus 3x plus 2 equals 0. We moved them to the opposite side of the equation, so their signs should change. So instead of being negative 3x and negative 2, they are positive 3x and positive 2. So now I need a product of 2 with a sum of 3. That's going to be 2 times 1. So x plus 2, x plus 1 equals 0. So x plus 2 equals 0, x plus 1 equals 0. So x equals negative 2 and negative 1. And of course, I did say you probably should check these. So I'll show you how to check a problem. It's not very hard to check an equation. To check these, you're simply going to put in negative 2 and negative 1 separately into the original equation. Here's my original equation. I'm going to plug this in. So I will have x squared equals negative 3x minus 2. So I have negative 2 squared. Does that equal negative 3 times negative 2 minus 2? Negative 2 squared is positive 4. Does that equal 6 minus 2? Yes, it does. 6 minus 2 is 4. We can check the second part of this equation. Same thing. Now we're going to put in negative 1. So I have negative 1 squared. Does that equal negative 3 times negative 1 minus 2? This is going to be 1. That's going to equal 3 minus 2? Yes, it does. So we both check. That's how you check your equations to make sure they give you answers that are reasonable and correct. Here we go. Number 7, x squared plus 10x minus 25. It is not set equal to 0, so it's not in standard form. So we need to move over the 25. So I'm going to add the 25 to both sides. So we have x squared plus 10x plus 25 equals 0. So I have a product of 25 and a sum of 10. So that's 5 and 5. So I have x plus 5 times x plus 5 equals 0. So x plus 5 equals 0 and x plus 5 equals 0. So x equals negative 5. There's only one solution here. It just has what we would call a duplicity, or it comes up more than one time, so it's a multiple of 2. Okay, so our solution is negative 5. Next problem, number 8. 9x squared minus 4 equals 0. That's in standard form. If you notice, it's a perfect square, isn't it? It's an a squared minus b squared, which factors to an a plus b times an a minus b, if you forgot. My a term is the square root of 9x squared, which is 3x. My b term is the square root of 4, which is 2. So I have 3x plus 2. 3x minus 2 equals 0. So 3x plus 2 equals 0. 3x minus 2 equals 0. Subtract 2. Add 2. 3x equals negative 2. Divide that by 3. we get x equals negative 2/3. Here we have 3x equals 2, divide that by 3, and x equals positive 2/3. So it's negative 2/3 and positive 2/3. And we could check that into the original equation, and it should still work. Okay, if I wanted to check it, I will just show you checking one of the two. I'll do negative 2/3. So it says 9 times x squared. X is negative 2/3 squared minus 4 is supposed to equal 0. So let's take a look at this. Okay, 9 over 1 times negative 2 squared is 4. 3 squared is 9. So these cancel out, so 4 does equal 4. Checks. That's solving quadratic equations. It's not really hard when they stay in this simple form. They'll get more complex when you get into Algebra 2, but that's not for another couple of months still, or actually a little over a year, because you have to take geometry first. So this is solving quadratic equations.